All right, good morning. Can you hear me okay through the headphones? Great, okay. This is my first time doing a silent session. I'm trying to think of it kind of like the UN where they have those translation microphone or headphones. So it's kind of helping me get used to the idea. So hopefully you're hearing me okay. So good morning. Today we're going to be talking about using machine learning in the online car shopping process. I'm Jason Staley. I'm a solutions architect with AWS. And I focus mainly on digital customer experience, automotive, and AI on the side as well. And so we're going to hopefully have a good talk. We're going to be talking a lot about CarGurus' use of machine learning, and I'm going to be joined by Jason and Raghu from CarGurus, who are really going to go into how CarGurus specifically have used machine learning over the last few years. So I'm going to talk about industry trends in digital customer experience and machine learning. And then Jason and Raghu will talk about CarGurus' specific machine learning journey, and they'll get into the architecture and the platform that they built over time. So some of the big trends that we're seeing in machine learning with digital customer experience is these really large data sets really starting to become useful. So we are doing things with these large data sets. We can build more complex models. We can learn new insights. But to manage all of those large data models and machine learning models, we need better practices. We need automation. We need better operational practices to really make that flow better and be more useful overall. And we're going to get into that today. So apologies for the kind of cliched iceberg slide, but the general idea here is that at the top of the iceberg we see these AI applications, and they're really neat things that we're seeing, really neat innovations coming out across different industries. But what we don't always see is the amount of data work that takes to build those capabilities, right? So we need the data streaming and the data automation and the data governance and the data storage and databases and all the rest of it. And we need those to make sure that when we surface this in these AI applications, that it doesn't end up being garbage in, garbage out. And with that data, we're able to build out more and more sophisticated models, right? So we have these compute capabilities, we have these abilities to train models in massive scale, massive size. And there's a lot of really interesting things going on right now and a lot of things going on in generative AI. But one of the key things to remember is while generative AI is really good for things like images and for language and text and things like that, there is still a lot of problems to be solved with regular machine learning and deep learning. And so it's really important to keep that in mind, that there's still a lot to invest in the classic sense of machine learning and deep learning versus generative AI. And in the case of digital customer experience, we really want to help improve customer outcomes, right? We want relevant recommendations. We want to make good product recommendations or good service recommendations. We want great search results, right? We want things to be optimized for what that customer is interested in. And really the ultimate goal is, if we do it right, it's win-win, right? The customer gets the product that they're interested in, and we get a faster buying cycle. So that's really important to remember. There's a lot here going on, but we want that to be, we want both sides to benefit. But with personalization, it's not particularly useful or worthwhile if that personalization happens a month from now, right? If you have a drip campaign that fires off in a month or even a few days or even sometimes a few hours after the fact, that's nowhere near as powerful as if that recommendation was made while the user is in the website or in the app. We want to catch them as they're using the app, and that requires some really interesting engineering problems to solve, optimizations to have those things be seconds or sub-second type optimizations. So with those data sets, with those advanced models, with that real-time processing, right, there is a lot of stuff going on there. And it's really key to have really good machine learning operations practices in place, right? You want that automation. You want that governance. You want to have the awareness of what's going on at all times. So having that maturing process is going to be really, really important to make it work. Because ultimately what you want is you want a plug and play framework, right? You have the standard infrastructure, you have the standard processes, and what you want to be able to do is then take new models as your teams develop them and drop them in to those, into that kind of standardized environment, right? To speed things up. So you focus on the innovation in the model, but then it becomes part of a standard stack when it comes time to deploy it and test it. And basically, as your company goes through these different projects, what you want to always be doing is moving yourself forward on your maturity. You want to start with, maybe for example, you maybe just start with cloud-hosted notebooks. And then eventually you want to get to a repeatable stage where you have automated processes like continuous integration and continuous training and things like that. And then you want something that's more reliable. So then we're talking about things like continuous monitoring of your models, of your data, and then ultimately you want to get to that scalable stage where you can repeat the processes across different projects and across different teams. And so that's why CarGurus is here today. They've done a great job moving along this axis here to that scalable stage. And so I'm going to have Jason come up now from CarGurus, the senior manager of data science, and he's going to talk more about CarGurus' journey. Thank you. Thank you.
Thank you, Jason. Yes, I'm really excited to be here today and be able to talk to you all about CarGurus, tell you about what we do, and how data and machine learning are an absolutely essential part of the equation. So CarGurus is an online automotive platform. We bring together automotive dealerships with car shopping consumers. We provide products and tools to help both types of customers with every stage of the car shopping process. For our dealership customers, that begins with inventory sourcing and acquisition, where we're giving access to the wholesale markets through our subsidiary CarOffer, as well as the ability to acquire inventory directly from consumers through online trade-in and car selling processes. A dealership will then list their inventory with CarGurus, giving them the ability to market, sell, and gain exposure to one of the largest consumer audiences amongst online automotive marketplaces in the US. For a car shopper, they would generally come to CarGurus, of course, generally looking to buy a new car. Some people just like to browse and look at cool stuff, but most of our customers are looking to buy a new car. And for them, we offer research tools to be able to sort of start narrowing down and scoping out what they're in the market for. We offer really sophisticated search and recommendations capabilities, surfacing relevant listings from amongst our set of inventory, which is really the largest in the US. We then allow our users to connect with the dealership, find that piece of inventory that they might like to make a purchase on. We also offer, for the whole spectrum of the shopping experience, tools for financing and for trade-ins and selling your car online. We're a multinational business with a presence in the US, Canada, and the UK. So I think CarGurus is a really great business model, but as a data scientist, the thing that really gets me excited and motivated to come to work every day, of course, is our data. It's what's kind of enabled by this kind of two-sided marketplace business model, combined with the scale and reach at which we operate. It gives us a really sort of unique and powerful data set covering the automotive marketplace. As I mentioned, we boast an industry-leading selection of inventory listings sourced from over 24,000 dealerships in the US. And each one of those listings just contains a wealth of detailed information about a car that's out there for sale. You'll have like its make, its model, trim levels, its price, its history, lots of great photographs. So putting that together, and again at the scale that we operate at, that gives us really an unparalleled view into the supply side of the auto market. We also have great coverage on the demand side. We're attracting over 30 million visitors every month in the US and making over 80 million sessions monthly. So these are motivated shoppers in the market for a new car. They're researching, comparing, submitting leads to dealerships, spread across many geographical areas. So with that data, we're really able to then unlock opportunities to bring in machine learning and AI techniques to uncover trends and patterns in the automotive marketplace, and in turn, build better products, better features for our customers. So sort of, it shouldn't be a surprise then, given our sort of great data assets, that machine learning and data-driven products have really been an essential part of CarGurus from our earliest days. On this slide, I really just have the tip of the iceberg as far as product features that are powered, by machine learning, by data at CarGurus. We have many more applications than just these. We have internal applications as well. But some of the places that we leverage heavily ML recommendations, which Jason mentioned a little bit earlier, of course, common across the industry, very important for an e-commerce site in general and for a car shopping one like ours. We have AI, sort of enhancing aspects of our search. We leverage data in our marketing strategy to really optimize and get the most ROI out of our ad spend. And then finally, one that I'll do a little bit of a deep dive on for you today, where we're really pulling in that supply side inventory data, is to understand vehicle pricing and fair market price through what we call our instant market value algorithms. I'll turn now to tell you more about instant market value. So this is really one of the first data-driven products or product features that CarGurus had, and it really differentiated ourselves from our competitors. I assume, how many of you have kind of shopped for a car recently, like in the last couple of years? Okay, and hopefully you all got like a great deal and felt really good about the price you paid. But maybe some of you, weren't so sure that you had all the information you needed to make a good decision, weren't so sure that that price you were getting was the best possible price for what you ended up with. The car industry is kind of notorious for not being the most transparent from a consumer perspective as far as knowing what's a good value. And there's a lot of information asymmetry between the dealership side and the consumer side. So CarGurus sort of saw this opportunity to fill in that information gap, again, leveraging our data, and bring trust and transparency to car shoppers. So give you a sense of how it works. We've sort of built this IMV, instant market value IMV algorithm. It pulls in lots of features of the inventory listings that we have on the site that I mentioned earlier. Those features include, the make, the model, the trim and options level of the vehicle, just kind of the basics. Its age, its history, how many miles are on it, condition, previous owners. We'll then look sort of within the geographical region where that vehicle is available for sale. We'll compare it to similar listings and try to use that to see what's the fair market price, within that region. And we'll update it, dynamically as the market shifts. So that kind of process of building a model to get the fair market price, the output of that is the IMV, the value that we're estimating at for each listing on our site. We'll then compare that IMV to the listing price that the vehicle is being offered at to assign a deal rating. So if it's being listed well below the IMV, that's a good or a great deal. It's kind of on par with the IMV, that's a fair deal, and potentially some could be overpriced as well, and we'd give our consumers that information. So kind of given how central IMV is to some of the value proposition that CarGurus provides to the market, it shouldn't be a surprise that it's really embedded throughout our product. The most sort of central and significant is probably in search, where the deal rating, good, great, fair, of a listing will influence sort of how it ranks, and we're going to try to let the better rated, the better deals float to the top of our search results. We're going to display those deal ratings prominently on the search results themselves with badging. But beyond search, I mentioned earlier, we also offer tools to help consumers with trade-ins and with selling their car. And one of those is kind of a calculator where you can understand, what you can expect to get if you do trade in your car or sell your car online. And that valuation tool is itself powered by the same IMV algorithm. And finally, there's applications for our dealer customers as well. We can offer tools to our dealers to help them look at the deal ratings of their inventory and understand kind of how competitively they're pricing their inventory relative to their market. So IMV is very important to us. It's also a very hard problem. It's an especially hard problem for used vehicles, which turn out to be actually what most auto shoppers are in the market for. And the reason for that is that kind of unlike a lot of categories of merchandise that are sort of commoditized, or even unlike new vehicles where you have an MSRP and kind of a lot of standardization, every used listing is really its own unique, special kind of snowflake. And it has its own unique history that influences its value on the market. So the consequence of that is that in order to assign an IMV, a value to a listing, we need comparables. We need to find other listings in the market that are similar, that we can kind of get a sense of where that value sits. And if a listing is kind of too special, it's a less common make model, it's older, it's in a thinner geographical area. In those situations, we can't assign an accurate value. And because our goal here is trust and transparency to our users, accuracy is absolutely paramount. So if we can't assign an accurate value that we're confident in, then we just can't assign a deal rating to that listing. So that's a situation that we want to avoid. We want to be able to assign accurate deal ratings to all of our listings. So to kind of get you thinking a little bit about this problem, I just want you to think of the example of, imagine there's a used Tesla Model 3. So Tesla Model 3, it's been on the market for a few years now, but not as long as more established brands, and especially on the used market, probably not as long as many more established makes and models. And of course, the Tesla Model 3, it's an EV, it's an electric vehicle, of course, right? So maybe when we're trying to assign a value to it, we should look at other EVs, used EVs in the market. But Tesla Model 3 is also a luxury sedan. And there's lots of other luxury sedans that are not EVs that maybe we have more data on. Maybe they've been, the same model's been on the used market longer. So what do we do about the Tesla? Do we lean on the EV data? Do we lean on the luxury sedan data? Do we kind of combine them? How much weight do we give to each feature? And I don't have an answer for you today on that question. It's the only way we can answer that question is by using our data. And it's going to change. It's going to change with the market, with the price of gas and incentives for EVs and all of that. So this type of problem is one where the solution is to bring data to bear and bring models to bear that can understand these trends. So we've, of course, been on a process of continuously improving our IMV algorithm, trying to improve the accuracy, trying to extend coverage, assign a deal rating to as many listings as we possibly can. We've done that by leveraging our data, by pulling in more features, more sophisticated features, and then adopting more powerful machine learning techniques to actually be able to take advantage of that better data. Also, because as I told you, IMV has many kind of use cases, many clients in our product, we've also found it necessary to move to a microservices architecture, where we're able to kind of iterate on the core machine learning service while having multiple clients consuming that. So that's been part of where, migrating the IMV algorithm to AWS and to SageMaker, as I'll tell you about, has made this very easy for us to do. So with some of our recent iterations, we've been successful in demonstrating the ability to reduce the number of listings that don't get a deal rating by over 50%. That lets us put more inventory in front of our shoppers. And of course, the flip side of that is more exposure for our dealers. So this is a great win-win for the marketplace business. Okay, so IMV is one very important application of machine learning at CarGurus. Another one that Jason teed up is recommendations. So we do a number of things to personalize the experience of CarGurus for our users, including recommendations for listings that we think a user would find relevant. Here, the game is really about making those recommendations as relevant as possible. Car shopping is an interesting place to do this because we really have a limited window of time to learn about our users' preferences and kind of show them the value, show them that we have relevant inventory. Think about it, a typical car buyer will probably be in the market for a car every 5 to 10 years, maybe. It's not like Amazon, where you might, an engaged Amazon user might be making purchases every day, and have that real lifetime value. We're much more episodic in that sense. And we're an online marketplace. So of course we have competitors. The switching costs are relatively low for a user to look at CarGurus and also look at another site. So we really want to make the most out of that time that we have with our users, again, to show them the most relevant listings and show them the value that they can get on CarGurus. So we sort of found, in addition to just better recommendations, we can also get more relevant by building more timely recommendations, by acting faster on the data that we have. So one thing that we'll tell you a little bit more about in this talk is how we've explored building a real-time data pipeline and real-time feature store to power some of this. Okay, so I've just given you a taste of some of the important applications of machine learning at CarGurus. And about 2 years ago, we sort of found ourselves in this position where we had a few models built, delivering value in production. And we knew, we had a roadmap. We wanted to build lots of new ones, lots of new applications. But we were kind of building models a little bit ad hoc, a little bit piecemeal. We weren't very standardized. There was a lot of friction in sort of a data scientist getting a model from that prototype stage and then deploying it and having it live in production. So we sort of sat down and realized we needed to invest in our tooling and our processes to eliminate some of those barriers to really scaling our machine learning operations. And so the first decision that we had to make, and of course the reason that we're here talking to you today, was to adopt Amazon SageMaker as the foundation layer for our machine learning platform. There were a few things about SageMaker that attracted us initially that we still get a tremendous amount of value out of. We really like how fully featured it is, how we have access to the entire suite of AWS services that we can integrate together to build a full end-to-end machine learning application. Because of course, most serious things need more than just a model endpoint. We like the flexibility of it, the ability to integrate with our existing tool chain. As I said, we kind of came to this already having some things built, some things that we didn't want to break. Support model, very important. The model's in production. And also they've had a great support model for kind of getting onboarded and sort of informing some of the early decisions that we made on what our best practices were and the tooling we would build on top of SageMaker, which we'll tell you about in this talk. So we made this adoption in 2022. And since that time, I've sort of been building our machine learning platform on top of SageMaker with some of our own sort of in-house tooling. Our goals there have been to support the entire machine learning lifecycle. We have data scientists that are taking models from the earliest stages, exploring, prototyping. We then need to bring those through to something that can be deployed, that can be tested at production scale, and then that can live as a production deploy model with ongoing monitoring and maintenance. We wanted to remove that friction from deployment. So that meant consistent execution between a data scientist building and running a model locally versus the same one in the cloud working on the same data, should behave identically. We had existing models when we built this thing, so we didn't want to break them. We didn't want to sort of do anything that would risk the value we were already delivering. So we wanted to kind of design a platform where we could plug in with minimal changes models that we had already built. And then a really important one that I think we'll spend a lot of time on in this talk was we needed to identify what were our team's best practices and patterns for leveraging SageMaker, leveraging these tools, and then enforce those in our platform, in our tool chain, so that our data scientists and ML engineers could really just do the right thing by default. And finally, again, looking to remove friction from deployment, we created scaffolding and sort of stub code to be able to build a skeleton of a project that would let you take a model, deploy it, have it running in the cloud within minutes. So where we are today, we've been living with this for about 2 years. At this point, all of our models are running on the platform that we built that we'll tell you about today. All of our new projects going forward are using this. We've kind of enforced those best practices that you'll hear more about in our tools, in our code. We're now able to bring a model from that prototype stage to production in weeks, whereas previously it could have taken months because of the lack of standardization, because of some of the friction involved in the process. And with that scaffolding and code generation tool set that I mentioned, we're able to sort of spin up a fully running end-to-end pipeline within a day. So that gives kind of a great starting point for a data scientist then to start, fleshing out the details. Okay, so with that, I'll turn it over to my colleague, Raghu, a senior machine learning engineer at CarGurus. We'll give you sort of a deep dive, a look under the hood of how our platform works. Thank you.
Thank you, Jason. Hello, everyone. I'm Raghu, and I'm really excited to be here to talk about our machine learning platform here at CarGurus. As you just heard from Jason, machine learning is central to the experience that we deliver to millions of users across our online automotive marketplace. As we grew our business over the years, so did our data, infrastructure complexity, machine learning use cases, and needs. To meet these growing demands, we worked hard to significantly evolve our machine learning platform. And now, looking back at our journey, if there's one thing that stands out, it is that implementing best practices was foundational to the success we've had in effectively scaling our marketplace with machine learning. Through our platform, we prioritized scalability, reproducibility, monitoring, and standardization across multiple machine learning workloads. We've also streamlined the entire machine learning operational lifecycle, from model development to deployment and beyond. Now, this is all made possible because we've heavily leveraged AWS services, including but not just limited to SageMaker. And today, I'll sort of go over our platform best practices and how a diverse set of AWS services and their features helped us implement them. But to give you a quick feel, we use cloud-hosted notebooks with SageMaker for quick experimentation and model prototyping. To productionalize our models, we use our in-house library, CG SageMaker, to establish patterns and best practices across our various projects and also to define our pipelines themselves. Our pipelines are SageMaker pipelines, and we continuously train and deliver new models using a combination of SageMaker pipelines and Amazon CloudWatch. So once we have like models that are trained, we deploy them as shadow variants to endpoints and perform extensive shadow testing on them using SageMaker's model shadow variants feature. And finally, to monitor our deployments, and by the way, deployments here are both pipelines and endpoints, we use Amazon CloudWatch and SageMaker Model Monitor. In the next few minutes, we'll cover each of these best practices in depth, and we'll also see how they're implemented. Our data scientists typically use Jupyter notebooks on the local machines for exploratory data analysis and to build and evaluate new models. But there are times when their local machines just can't keep up. Think of scenarios where you're dealing with large data sets or when you need accelerated compute power or GPUs for your training jobs. In those situations, SageMaker notebooks actually help us a lot because they provide a fully self-service option in the sense that our data scientists can, with just a few clicks, spin up a GPU-accelerated or compute-optimized instance in AWS. And they also make lives easy for our machine learning engineers because all we need to do is set up network configuration so that the notebooks run behind our VPC in a safe and secure manner. And we also track costs from time to time as well. Now, it's important to note that we use SageMaker notebooks only for prototyping models. For production workloads, we prefer to use SageMaker pipelines as they offer a greater feature set and maintainability. So I've briefly mentioned that CG SageMaker is our in-house framework, and it helps establish patterns and enforce best practices. But in my mind, that's a pretty vague definition. So what exactly is CG SageMaker? In simple terms, CG SageMaker is a Python library that helps us define SageMaker pipelines for various projects in a streamlined fashion across the team. You can think of it as a wrapper around Bodo 3. You can also think of it as an infrastructure as code pattern, as it not only helps you store pipeline definitions in Python code, but also lets you dynamically configure options such as instance type, instance count, and storage size of the pipeline steps according to data and model requirements. Now, our design philosophy for CG SageMaker is centered around enhancing the developer experience for both our data scientists and machine learning engineers, which is why it follows a declarative approach. In practice, this has multiple benefits. First, CG SageMaker implements platform operations by abstracting away complex inner logic that interacts with several AWS services through Bodo 3 calls, and we'll get into this later. Second, CG SageMaker provides a template for our data scientists to quickly bootstrap their projects, and through standardized interfaces to SageMaker helps us enforce patterns and best practices from the get-go across all new projects. Now, I've talked about our internal framework, and I think we can proceed with deep dives on the rest of the best practices. But before that, I want to actually talk about the use cases very quick with CG SageMaker. So we run pipelines in production, development, staging, and production at any time using CG SageMaker, and pipelines, again, are Python code. And then there's pipeline scheduling, where we automate the timing of our pipelines by setting up event bridge rules so that they run continuously in a recurring manner. And then we use CG SageMaker for also a fail-safe shutdown and deployment of endpoints, and a topic related to model promotion, which I will get into later. We also rely on CG SageMaker to interact with our model registry to list available models and the metadata like performance metrics. And finally, we have built-in commands in CG SageMaker to track costs and resource usage across our SageMaker endpoints and SageMaker notebook instances. So our training pipelines actually go beyond training and maintaining accurate models. They implement the best practice of deploying models as shadow variants in a fail-safe manner to SageMaker endpoints that exist in staging environments. And now that's a lot, and I'll try to break it down. As I click through, what you'll see is a slowly forming DAG of our IMV pipeline on the right. We have ingest and process our first two steps. They connect to our data warehouse Snowflake and run extract transform and load operations, or ETL processes, to prepare it for training, prepare data for training. The next two steps are train and evaluate, the pretty cut and dry, the train and evaluate a model. And at this point, we have a trained model. Now, the create model step takes this trained model and links the model code container from ECR with the model's artifacts such as weights stored in S3, and creates a SageMaker model definition. SageMaker model definition, in my mind, is sort of like an abstraction of a machine learning model, and that's how I think about it. Downstream, there are three steps that run in parallel. The register model step stores the model definition into the model registry, along with the model's performance metrics. The deploy test endpoint step is a Lambda step that spins a test endpoint based on the model definition. And Lambda steps here are specialized pipeline steps provided by SageMaker that are meant for lightweight deployments, and they fit our use case perfectly. Downstream, the test API step, which is also a Lambda step, invokes the test endpoint we just created and verifies the canonical correctness of the responses received from the model, from the endpoint. Now, the key point here is the deploy test endpoint and the test API steps. Both of them are responsible for simulating how a client would send us traffic and also validate the model's behavior in responding to that traffic. If all tests pass, the deploy shadow variant step, which is also a Lambda step, deploys the model definition as a shadow variant to an existing endpoint which already has a production variant. Note that this is not actually model promotion. We are deploying it as a shadow in the sense that we want to run extensive shadow testing on it, on live traffic, and then later decide to see if we want to promote it or not. So now that we have our training pipelines defined, and those pipelines are actually able to handle deployments, the next best practice is to automatically run these training pipelines on a recurring schedule to keep our models up to date. For this, we again leverage SageMaker to create an event bridge rule that runs on a set schedule specified by a cron job expression. The rule, when it runs, triggers a Lambda function that pulls a pipeline definition from ECR. Pipeline definition is, again, Python code, and then runs a SageMaker pipeline using that definition. You've seen from the earlier slide that our pipelines handle deployments. So what actually ends up happening here is our scheduled pipeline runs successfully train a model, store that in a model registry, and then also deploy that as a shadow variant to an endpoint. Now, with scheduling in place, we can now turn our focus onto monitoring our deployments over time. And again, deployments here are not just endpoints, but also pipelines, as pipelines are scheduled. This best practice has two key elements to it. First, we monitor the operational health and stability of our endpoints, and also track whether our pipelines are running without failures and on schedule. And for that, we use Amazon CloudWatch dashboard and alarms to track key performance indicators such as CPU usage, latency, and throughput, the usual suspects, and pass them along to an Amazon SNS topic. And this Amazon SNS topic is linked to our incident management system, and our on-call machine learning engineers receive alerts if there's an event such as a downtime or a failed pipeline execution, and then they respond to those alerts. Second, we also continually assess the model quality of our endpoints over time by enabling a feature called data capture. And data capture is a feature in SageMaker endpoints which lets us log the input and output of our endpoints to files in S3. And these logs are eventually then ingested to our data warehouse, after which our data scientists can perform offline analysis and then assess the model's quality. We've made it so far. So far, our pipelines continuously train new models and deploy them as endpoints. And we've also implemented monitoring across all our deployments over time. And thanks to all our platform best practices so far, we now have enough observability to promote models to production. Now, before we do that, why do you even want to promote a model to production? As silly it may sound, I think it's beneficial to have that discussion. And also, what's the current state, right? Reviewing the current state right now is a good thing to do. So we have a SageMaker endpoint that has two models, a production variant and a shadow variant. We are monitoring the health of these variants using Amazon CloudWatch. And we're also assessing the model quality using data capture feature. At this point, the shadow variant is generating inferences for 100% of live traffic, but it's not really responding to any of the client requests from the client service. That's all handled by the production variant. Operationally speaking, we're in a steady state, or a healthy state. We can keep this setup however long we want in production without running into errors. But in reality, we all know model quality degrades over time, and this is especially true for vehicle pricing, which exists in a dynamic market. So if the objective of the IMV service is to deliver accurate vehicle predictions, it is in our best interest to keep our models up to date. But we know that the shadow variants are always kept up to date by our training pipelines. So to do this, to promote a model, we just take a look at the shadow variant and see if its model quality, performance metrics cross a threshold for promotion. And then using CG SageMaker, simply swap the production variant with the shadow variant. After the swap is complete, the shadow variant now responds to 100% of client traffic. Optionally, we can even select a model from the model registry using CG SageMaker to deploy that as a shadow variant and then promote that model as a production variant. In this manner, we're able to keep our models up to date, deliver accurate pricing with minimal effort, but also involving a human in the loop for oversight. Now I'll hand it back to Jason, who's going to talk about the exciting world of sophisticated recommendations powered by real-time feature store.
Okay. So one other area that is a little bit different from our core machine learning platform that Raghu walked you through is this idea of a real-time data pipeline for recommendations. So when we built this, we sort of had a situation where we knew we wanted to test this idea of getting our recommendations lower latency near real time. But we had a relatively small team that we were going to do it with. So we sort of came to this with a few requirements in mind in order to be successful. We decided we were going to build it using managed services, which really meant using the potential of running on AWS and leveraging SageMaker. Like any machine learning project, consistency between training and inference, very important. You want your model to behave when it's deployed the same as you expected it would behave when you trained and evaluated it. But that can be very difficult to achieve in a real-time context, as anybody who has experience building these types of systems is probably familiar with. And then finally, we came to this with some pre-existing models. And kind of as a theme I've been saying is we don't want to break what already works. So we already had some of our features defined for recommendations with existing SQL Python code. We really wanted to be able to leverage that again and use that same code when we move to this real-time world. So the solution that we landed on, I'll walk you through, starts with treating Kinesis as our source for just raw event data, clickstream data. We adopted Apache Flink and the managed service for Flink that Amazon provides as our kind of computational engine for our streaming data pipeline. One of the reasons there was that it's available as a managed service, and the other one was through the Flink table API, we were able to reuse some of that SQL-based feature definitions that we already had. So the initial Flink job here is parsing out the event streams, filtering, and then splitting those events into subsets of event types. So an important one would be just page views. What pages on our site is a user visiting? And we'll have a subset of features for the model that are just based on digesting that page view event type. And then we'll have other event types with parallel pipelines. For each of these, we're going to buffer the events in Kafka, again leveraging MSK as a managed Kafka solution. And then those filtered and buffered events are then pulled into a subsequent Flink compute stage, which is really doing the heavy lifting of defining the features and generating them. So it's doing augmentation of the data, it's doing transformations, doing aggregations to really kind of generate the feature values that will feed into the model. We bring together these different event types, buffer them again through a final Kafka stage where they can be picked up through ingestion jobs that feed into our real-time feature store, which we adopted Elasticache to be the data store for. And there's a parallel pipeline outputting the same feature values to our data warehouse for training and offline analysis. So that pipeline is going to bring events as they're occurring, going to feed them through. It's going to end up updating those feature values that are held in that Elasticache feature store. And that's then what's made available to the model. So when we want to serve a recommendation on the site, a call is made to a SageMaker endpoint. It hosts a model, like the ones that Raghu walked you through. And when that call is made, the model will go to Elasticache, get the features that it needs to serve the recommendations. So this architecture, it worked pretty well for us in the sense that we were able to achieve our goals that we set out to do to build this real-time pipeline. It's a non-trivial thing to build. So we really felt like our bet on managed services as kind of the foundation for this, that did pay off. It didn't come for free. At the sort of scale that we needed to operate this and at the complexity of integrating services together in the way that I showed you, we definitely hit some friction. We hit some points where we needed to expose some hidden configuration values or metrics of these services that may not have been available by default. And these were sort of things that only emerged when we built this end-to-end system and ran our full scale of data through it. So there were some really interesting engineering challenges to work through. And that introduced some trade-offs that we had to make. Of course, I said we had this goal of consistency between our training and inference features. We'd like that consistency to be perfect. But with real-time architectures like this one, there are real limitations. There's real limitations on how sophisticated and large scale of a computation you can do while maintaining the throughput that you need and the low latency. So we did find it necessary to simplify some of our feature definitions to limit that complexity. And one of the things that really helped here was actually involving, this was mostly a project built by our machine learning engineers, but we found it really helpful to involve our data scientists in sort of evaluating the performance of the system and weighing these trade-offs, these engineering trade-offs that were necessary to make. So our data scientists were able to sort of retrain models and run analyses to say, how important are certain features, and how important is it that they have, how complex does the computation need to be, and how much data they need to ingest to still serve the final predictive value that we need. So our data scientists were able to kind of measure these things, measure how the engineering simplifications we wanted to make would impact the quality of the final output of the model, and then sort of make the trade-offs in a smart, informed way. So that way of working was really pretty successful with this project. Okay, so to wrap it up, I think we've given you a taste today of how CarGurus has leveraged machine learning, and I hope we've kind of given you a feel for some of the big steps that we've taken as we've walked along this maturity curve that Jason started us out with. I think we came from a world where we were doing kind of ad hoc and bespoke development of data science and machine learning models. And by adopting a machine learning platform, by defining our best practices and encoding those into our tooling, we've really been able to achieve a repeatable, reliable process and built a platform for new machine learning development that has proven itself to be a sound foundation for scaling what we do and sort of continuously delivering value through machine learning to our customers. So I think just a few of the takeaways that I hope you'll find from our experience. Really, we've found it so important, to streamline and standardize. That has been kind of the thing that's unlocked our ability to scale and move more quickly and with more confidence. It's worth sort of taking that time. If you're a data science and machine learning AI team, it's worth taking that time to understand for your team, for your business context, what are those best practices in using these tools that are most important, that are most aligned with the value that you need to deliver. And then having sort of defined those best practices, going that one step further to really automate them, automate your operations, build it into tooling, make it something real and tangible that just encourages everybody on the team who's developing to do the right thing by default. We've seen that formula really drive a lot of success for us. And we don't see it as something where we've kind of hit an end. This is a ongoing journey for us where we're always learning and always iterating, and we're really excited to see where it leads. So with that, I'll conclude, and thank you all very much. It's been a pleasure to share with you machine learning at CarGurus. If you have any questions, we'll hang around. Happy to talk. And please complete the survey and enjoy the rest of your day, rest of the conference. Thank you very much.